Rolling contact bearing. A bearing is defined as a machine member whose primary function is to support and retain a moving member. In rolling contact bearing, the contact between the two surfaces is rolling. In rolling bearings, the shaft and the outer members are separated by means of rolling elements, for example balls, rollers, needles, etc. In rolling contact bearing, load is transferred through the elements in rolling contact rather than sliding contact. These bearings are manufactured to take pure radial load, pure thrust load, or a combination of two. In this bearing, the contact area is small compared to sliding bearing, and as the stress is high, the rolling elements are made of hardened and high-strength material as compared to shaft or other part of the bearing. Motion of the bearing may be of following two types: rotary motion, 2, translatory motion. These type of bearing can take load under both type of motion. As the friction offered by such bearing is very low compared to other nature of bearing, they are also called anti-friction bearing. Linear bearings. Advantages: 1. Low starting and low running friction. Low friction can be obtained in case of sliding bearing in case of the full film lubrication. It is possible in hydrostatic lubrication and it is very costly. 2. Ability to withstand momentary shock loads. 3. Accuracy of shaft alignment. 4. Low cost of maintenance, as no lubrication is required while in service. 5. Rolling bearing gives warning prior to failure, whereas sliding bearing failure is sudden and hence more dangerous compared to rolling bearing. 6. Reliability of service. 7. Easy to mount and erect. 8. Cleanliness. Disadvantages: 1. More noisy at very high speeds. 2. Low resistance to shock loading. 3. More initial cost. 4. Design of bearing housing complicated. Types of rolling contact bearings. Following are the two types of rolling contact bearings. 1. Ball bearings, and 2. Roller bearings. A number of balls or rollers are used, and these are held at proper distances by retainers so that they do not touch each other. The retainers are thin strips and is usually in two parts which are assembled after the balls have been properly spaced. The ball bearings are used for light loads and the roller bearings are used for heavier loads. Types of bearing. Bearing are classified as following. Based on direction of load, generally axial or thrust and radial loads are taken up by rolling bearing. If the load is perpendicular to the axis of the shaft, then the bearing is known as radial bearing. If the load action is parallel to the axis of the shaft, it is thrust bearing. Figure 17.1a shows a radial bearing with translatory motion and radial load. Figure 17.1b shows a thrust bearing in which a thrust load is applied. The inner part is stationary whereas outer part is rotating. Standard dimension and nomenclature of rolling bearings. The dimensions of the rolling bearing are standardized as shown in figure. As per international standardization, bearing are standardized as a function of bearing bore and load carrying capacity of the bearing represented by series of the bearing. The bearings are designated by I, number series consisting of at least 3 digits. The most common bearings are available in following series. A. 100 series, used for very light duty or very low load capacity bearings. B. 200 series, used for light duty or low load capacity bearings. C. 300 series, used for medium duty or medium load capacity bearings. D. 400 series, used for heavy duty or heavy load capacity bearings. 2. Additional letters or digits are used to indicate any special features of the bearing. Example: sometimes B is used for ball bearing. Bearing manufacturers' catalogs identify a bearing by such numbers, giving a complete dimensional description. rated load capacities etc. For medium and heavy series bearing, the last two numbers when multiplied by 5 gives the bore of that bearing. Example: a bearing designated as 309 indicates that the bearing is meant for medium capacity, 300 series, and bore is 09 by 5 equals 45 mm. Note: 1. The extra light and light series are used where the loads are moderate and shaft sizes are comparatively large, and also where available space is limited. 2. The medium series has a capacity 30 to 40% over the light series. 4. The heavy series has 20 to 30% capacity over the medium series. This series is not used extensively in industrial applications. Types of radial ball bearings. Following are the various types of radial ball bearings. 1. Single row deep groove bearing. During assembly of this bearing, the races are offset and the maximum number of balls are placed between the races. The races are then centered and the balls are symmetrically located by the use of a retainer or cage. The deep groove ball bearings are used due to their high load carrying capacity and suitability for high running speeds. The load carrying capacity of a ball bearing is related to the size and number of the balls. 2. Filling notch bearing. Filling notch bearing is shown in figure B. These bearings have notches in the inner and outer races which permit more balls to be inserted than in a deep groove ball bearings. The notches do not extend to the bottom of the raceway, and therefore the balls inserted through the notches must be forced in position. Since this type of bearing contains larger number of balls than a corresponding unnotched one, therefore it has a larger bearing load capacity. 3. Angular contact bearing. 3. Angular contact bearing. An angular contact bearing is shown in Fig. C. These bearings have one side of the outer race cut away to permit the insertion of more balls than in a deep groove bearing, but without having a notch cut into both races. This permits the bearing to carry a relatively large axial load in one direction while also carrying a relatively large radial load. The angular contact bearings are usually used in pairs so that thrust loads may be carried in either direction. 4. Double row bearing. A double row bearing is shown in figure D. These bearings may be made with radial or angular contact between the balls and races. The double row bearing is appreciably narrower than two single row bearings. The load capacity of such bearings is slightly less than twice that of a single row bearing. 5. Self-aligning bearing. A self-aligning bearing is shown in figure E. These bearings permit shaft deflections within 2 to 3 degrees. It may be noted that normal clearance in a ball bearing are too small to accommodate any appreciable misalignment of the shaft relative to the housing. If the unit is assembled with shaft misalignment present, then the bearing will be subjected to a load that may be in excess of the design value and premature failure may occur. Following are the two types of self-aligning bearings. A. Externally self-aligning bearing, and B. Internally self-aligning bearing. In an externally self-aligning bearing, the outside diameter of the outer race is ground to a spherical surface which fits in a mating spherical surface in a housing. In case of internally self-aligning bearing, the inner surface of the outer race is ground to a spherical surface. Consequently, the outer race may be displaced through a small angle without interfering with the normal operation of the bearing. The internally self-aligning ball bearing is interchangeable with other ball bearings. Thrust ball bearings. The thrust ball bearings are used for carrying thrust loads exclusively and at speeds below 2000 revolutions per minute at high speeds. Centrifugal force causes the balls to be forced out of the races. Therefore, at high speeds, it is recommended that angular contact ball bearings should be used in place of thrust ball bearings. Thrust ball bearing may be a single direction, flat face as shown in figure A, or a double direction with flat face as shown in figure B. Thrust ball bearings are separable, i.e. Thrust ball bearings are separable, i.e. the shaft washer, housing washers, ball and cage assemblies can be mounted separately. Shaft washers have a ground bore to enable an interference fit. The bore of the housing washer is turned and always larger than the shaft washer bore. Types of roller bearings. Following are the principal types of roller bearings. 1. Cylindrical roller bearings. These bearings have short rollers guided in a cage. These bearings are relatively rigid against radial motion and have the lowest coefficient of friction of any form of heavy-duty rolling contact bearings. Such type of bearings are used in high-speed service. 2. Spherical roller bearings. These are self-aligning bearings. 2. Spherical roller bearings. These are self-aligning bearings. The self-aligning feature is achieved by grinding one of the races in the form of sphere. These bearings can normally tolerate angular misalignment in the order of ±3/2 of a degree. And when used with a double row of rollers, these can carry thrust loads in either direction. 3. Needle roller bearings. 3. Needle roller bearings. These bearings are relatively slender and completely fill the space so that neither a cage nor a retainer is needed. These bearings are used when heavy loads are to be carried with an oscillatory motion, for example piston pin bearings in heavy-duty diesel engines, where the reversal of motion tends to keep the rollers in correct alignment. 4. Tapered roller bearings. 4. Tapered roller bearings. The rollers and raceways of these bearings are truncated cones whose elements intersect at a common point. Such type of bearings can carry both radial and thrust loads. These bearings are available in various combinations as double row bearings and with different cone angles for use with different relative magnitudes of radial and thrust loads.